Alright, this is Cal 1 Applications of Differentiation. We're working optimization problems. In this particular problem here, well, let's just read it. I think I actually need to put a period maybe right there. Okay, we got to find the length and width of a rectangle that has a given area of 121 square feet and a minimum perimeter. All right, so let's go ahead and translate that into some equations and see what we can do from there. So we're trying to minimize the perimeter. Alright, so once again we're working with a rectangle, and I'll try to sketch a rectangle out over here the best I can. We'll call this the width, this the length. So our unknowns are L and W, and of course that number that we need to remember was the perimeter was 121 square feet. Okay, we'll just do that, square feet. Alright, I'm going to go ahead and write down, go ahead and write our equations down here. We are, okay, trying to remember what I had going on here. We've got the perimeter, and it's equal to 2W plus 2L. And of course, this is what we were trying to minimize, and I'll just write MIN. I think I was writing it over here to the left. But this is what we're going to try to minimize. This is our primary equation, but P doesn't stand for primary, it stands for perimeter. Right? And we have the area, and the area is length times width is equal to, and I believe I used, 121. Okay. So there it is. We have our two equations set up here, and we want to go ahead and get our primary equation all in terms of one variable. It doesn't matter which one you solve for, L or W, makes no difference. We're going to go ahead and solve for L here, and so we have 121 over W. Now I'm going to go ahead and take this and plug this into the primary equation so we can get everything in terms of one variable, and in this particular case it's going to all be in terms of W. So I'm going to put in our 121 here, W times, what am I doing? Where am I at? I'm up here. Okay. Let me back up. Okay. 2W plus 2L, and this is our L. I'll just put it in parentheses, 121 over W. Go ahead. Let's see, that's going to be 242. Is that right? 242, and I'm going to go ahead and take this W and bring it up into the numerator. Now of course what we're going to want to do now is take the derivative, right, and we'll say P prime, we have 2 minus 242 W to the negative 2. We're going to rewrite this again. Right, just taking this back down to the denominator. Now of course we take our derivative, set it equal to 0, set that equal to 0, and now what we're going to want to do is solve for W. Right, we want to solve for W, and I'm going to go ahead and bring the 242 over. We have W squared. Then I'm going to go ahead and rewrite this again. 242 is equal to 2 times W squared. Multiplying both sides by a half, we're back down to 121 is equal to W squared, and then we square root 121, and you know it's always plus or minus here, but of course we're not going to be working